All right, so on this README, we already have our kind of introduction to recursion. It's a function that calls itself. We use it to take big problems and continuously break it down into smaller problems, aka divide and conquer. So we're trying to, whenever we do one of these things, our first task is to figure out what the base case is, and then our second task is to figure out what the recursive case is. And if you find those two cases, you've done 50% of the work with this already. So I'm going to open this up. Would people rather see me do these in JavaScript or Python? Don't have time for both. Any preferences?
Python.
Python? Okay, we'll do it in Python then. All right, so I'm not going to spend too much time on making the spec file here, just because we've reviewed that several times already, and I think at this point you all know what a spec file looks like. So let's kind of go over these one by one. So first is factorial. And if anyone doesn't remember, a factorial problem is you take a number that, in this case, x, and you have to return that number times every integer below it down to 1. So to do this in a recursive way, we need to figure out what the base case is and the non-base case. So let's say that right now. What is the base case for a recursive factorial problem? Keeping in mind that we want to break x down into a smaller and smaller problem.
You have a base case of 0 and 1.
So a base case of 0 and 1, meaning that, so how does that, relating to x, how would we put that?
So if x equals 0 or x equals 1, return 1.
Yeah. So another way to write that could be if x is less than or equal to 1.
Yeah.
Return 1. And what's our recursive case?
It'll be x times factorial x minus 1.
Else return x times factorial with x minus 1 as the argument there. So this is one of those things that's easy to write out, but it's kind of hard to picture sometimes, right? So one thing I'm actually going to do is I'm going to go to this place called pythontutor.com. I think we put that on the README. Did anyone actually use it?
Yeah, I did.
Yeah, it's really, really helpful for understanding both the call stack and recursive methods. So I'm actually going to code this out here and then put it into our into Python Tutor to see, kind of visualize what happens. So I could just type this out. If x is less than or equal to 1, return 1. Else, return x times factorial x minus 1. So very easy to write out, but let's take a look at actually how it works. So I'm going to paste this function here and then call it on 4. So then I'm going to hit, wrong button. I'm going to hit visualize execution. So what this lets me do is it actually lets me step through the code frame by frame. So it says here, okay, I've defined a factorial function. In the global frame, here's the object, factorial x. Then I call it, x is 4. So we say, if x is less than or equal to 1, it's not. We go to our else, return x times factorial x minus 1. So now we call factorial with x equal to 3. And so it goes all the way down until x is less than or equal to 1. Once it is, x is less than or equal to 1. Here's our red arrow. We return 1. So it says here, return value of 1. This function gets taken off the call stack. And then this function, this version of the function calls it, saying x times the return value of the last one. So 2 times 1 is 2. Takes off the call stack. Gets me 6. Remove from the call stack 24. Gives me my final answer, which is 24. So that's what's going on behind the scenes here, is essentially every time we call on our recursive function, it gets put onto the call stack, and then once we hit our base case, it's kind of like a cascading effect where everything gets kind of taken off of the call stack one by one until you get to the very first call of the function. What questions do you have about what actually happened here? Okay, does this feel like something that makes sense that you could explain if you had to?
Yeah.
Okay. All right, let's try Palindrome next then. So Palindrome, again, we need to find a function that'll take a string and be able to we'll be able to take a string and tell us whether or not it's a palindrome, meaning it's the same forward and backwards. All right, so again, let's start with what's our base case? Remember, we're taking this string and trying to break it down into smaller and smaller pieces. So how do we know that we've...
Oh,
Go ahead.
be when string length is equal to or less than 1.
Length of string less than or equal to 1.
Yes.
Because we're going to be keeping on taking off. We know we're going to be breaking this down to smaller pieces. So if we get to one letter, we know, okay, every other kind of pair of letters has been the same. And that's actually one base case. We're going to have another base case, right? This is for the kind of the failure base case. What's the other thing that can cause this function to break out of the loop, as it were?
So what we did, we had if the first character in our string was not equal to the last character, and then we would return false.
Yep. First char of string does not equal last char of string. And then our recursive case would be anything else, right? We have the length of the string is greater than 1, and these two, and first character and last character are equal. So length of string is greater than 1, and first char equals last char. Okay. So does this make sense as our base cases and recursive case? Y'all are being awful quiet today.
Yes.
Was that in response to this making sense, or you being quiet?
Yes.
Both.
Fair. Okay, now that we have our base cases and recursive cases set up, we still have some pseudo coding to do, because unlike this one, there's more than just the base case and recursive case to code, right? So thinking back to the first time we did palindromes, what's the first step?
You got to make them you got to get rid of the spaces and special characters and make them lowercase or uppercase.
Yep. So get rid of special characters and convert to lowercase. That's just what I usually do. All right, then what?
Don't you have to make the string actual string just in case we're passing numbers?
Yeah, we may also want to convert to string just in case. All right, and then we want to do, so we do all that. And then I think once we've done that, then we can start to figure out our base cases, right? Say if len of string is less than or equal to 1, we return true. And if string, first character of string does not equal last character, we return false. And then finally, how do we do our base case? We'll want to return some. Yep, go ahead. Somebody was just talking there. Sorry I interrupted.
If first term.
I'm sorry, I didn't quite catch that.
No, sorry, I actually wasn't as confident as I thought I was.
Well, go for it go for it anyway.
No, a quick question. You said what do we have to do next for the base case?
Sorry, I meant the recursive case, excuse me.
Okay, I was like, wait, I thought we just.
Okay, that's why I was.
Oh, okay, sorry, my bad. So whenever we want to do something with a recursion, we have to return that, and we'll return palindrome, and we're passing it everything of the string except the first and last character, right?
Yeah, so we could do a splice.
Yeah, slice of string
Slice.
without first and last jar. All right, so now we have our pseudo code. So we could first say, what is this called? String. So we could say string equals str string, just in case. And then we have, I'm going to use that method that we figured out was it just Monday? Wow. Or maybe it was last week, I don't remember. Either way, I'm going to say, call this one, I can even just say string equals empty string dot join e for e in string if e dot is al num. So that'll loop through our string here, convert it to an array, but only include things that are numbers and letters, and then join turns them all back into a string again. All right. And then I can say if len of string is less than or equal to 1, we return true. Elif string 0 does not equal string -1, we return false. And then if neither of those pass, we can say we return, we want to return, what is this called? Palindrome with string, and we'll call this one, we want the slice from 1 to -1. Right, how does this solution make sense? Does anyone have questions about Palindrome, or we can also go back to Factorial if that's not something making sense either.
One thing I'm not seeing that we did was checking for capitalization here.
Oh, you're right. We didn't do that either. Thank you. So dot lower. There we go. All right, and we can just put some driver code here just to make sure. So we can say print palindrome with, I'm gonna do civic. So I do Python recursion challenge, like so. It returns true just like we thought it would. And if I do something like that, it returns false. Again, not proper spec coding, but it gets the job done for now. All right. Next, we've got 99 bottles, or just bottles in this case, because it can take any number of bottles. All right, so this one may be a bit trickier than the other two, because at the end of it, we want to go back and say, to go to the store, buy some more, and go back to the original number of bottles that was passed in the first place, right?
Yes.
So how did people solve that particular problem?
I know my partner and I, when we got to where we didn't need to recurse anymore, we did the hard code solution for the last couple lyrics.
Mm-hmm. All right, so you did the 2 bottles of beer on a more, 1 bottle of beer, taste one down, pass it around, and then you got to that. But how did you get back to the original number? Say I passed in 10 or 80 or 72.
We passed a second parameter to the original function and set it had it have a default value of num.
Yep. So a thing that can be very helpful when making recursive solutions to problems is using functions with optional arguments. So we could say something like original num. Excuse me.
Bless you.
Thank you. All right. All right, so using that, we can have a optional thing. So we can pass it in 99 the first time and then pass in 99 again for every subsequent call as a second argument. So now if we do our base case, what's our base case? Where we stop calling the function stops calling itself.
When count is equal to 2.
So if num equals 2.
Yeah, sorry, num.
Yeah. Is base case. I'm just going to write that here. And the recursive case is anything else. All right, so there's also kind of 2 ways to do this. We could just say have it print to the screen every single time, or we could do something like have it all combine into one long string and then print the entire thing at the end. I think I'm going to do it that way just for the extra challenge. So I'm going to say, so it means we'll have a string that we're going to be returning. So I'm going to have something that says, all right, if bottle equals 2, return last few lyrics. We know what the last few lyrics are. I'm not going to type it all out here. Else, we want to return So we're going to have, so what do we want to return if we want to complete, keep on adding up a string?
Bottles num -1.
Mm-hmm. Bottles with num -1 and num. But we also have like extra lyrics that we need to keep on adding every time, right?
Right.
So if we're adding this, like, trying to combine everything into one big string, what's our, what do we need to change?
Sorry, on the original, or on the recursive call, the second argument I think should be original num.
Yeah, original num. Thank you.
So if you have a number greater, if num is greater than 2.
Yep. Yeah, this is, so, yeah. So else if num is greater than 2. So one thing we can change to this to make sure we just like putting all one big string is I could say, bottle lyrics plus the return value of the next one. Let's try that. So I'm going to say if num equals 2. So I'm going to say return, this would be 2 bottles of beer on the wall. 2 bottles of beer. Put some new line characters. It's not working. Do I need to do, there we go. Take one down, pass it around, 1 bottle of beer on the wall. Another new line character, 1 bottle of beer on the wall, 1 bottle of beer. Take one down, pass it around. No bottles of beer on the wall. And then last one of these, no bottles of beer on the wall. So beer, go to the store, buy some more. And then we have to put in original num, bottles of beer on the wall. Okay. So we can say else. I'm going to return, so this would be num, bottles of beer on the wall. Num, bottles of beer. Take one down, pass it around. Num -1, bottles of beer on the wall. And then I'm going to put a new line character. And then I'm going to add bottles with num -1 and original num here. How does this look to everybody? Shall we test it out?
Sounds good.
All right, so I'm going to print bottles. Let's just do 5. I'm going to clear the screen here and then run the recursion challenge. Uh-oh. All right, so first problem. So num is not defined. So I can't set original num to have a base case, like have a, I can't set the default value here to be a variable that hasn't been defined yet. So one thing I can do is I can do none. And I could say, all right, if not original num equals num. So I'm saying, okay, if there isn't a variable called original num defined, or it doesn't have a value, then we set it equal to num, and that should only run the first time we go through this, and afterwards it shouldn't run at all.
Yeah, sorry, that was a JavaScript Python difference, because in JavaScript you can.
Mm-hmm. Yep, in
Yeah,
JavaScript that would work fine, but Python you can't. All right, and I can see here I've got 5 bottles of beer on the wall, 5 bottles of beer, 4, 3, 2, and then 1 bottle of beer on the wall, and then no bottles of beer, buy some more, 5 bottles of beer on the wall. All right.
No, I have a question.
Yeah.
Is there a way to set a default value when you create the function and have it so that someone using the function couldn't modify it?
So to make sure I
when
understand. So you set a default value to make sure that no one can run it? Is that what you said?
No one can change it. So if you ran bottles and then you put in two arguments, it would also reset your default value, would it?
Yes. So if I put in a second argument here, it would reset my... You're right. It would do that. I can't think of a way off the top of my head to make sure a user doesn't misuse the function. Besides putting a warning that says, you know, only call with one argument. This one is for internal purposes. There's probably a way to protect it, but I can't think of it off the top of my head.
So
But yes, if I called it with bottles and 10 right here, it would reset to 10 instead of 5 because, yeah, that would say, okay, there's something here, so we don't use the default argument. Does that answer your question, even if not satisfactorily?
oh yeah, it does.
Yeah, I guess you could like have a check to see if num is equal to original num before it even starts.
Yeah.
And if it's not, then you can just break it manually. I don't know.
Yeah. Yeah, we could say something like, instead of not original num, we could say, well, no, because that would break it the second time we go through if I said if original num doesn't equal num, because that's the entire point.
Right.
Yeah. So I can't think of a built-in way, at least, that would allow you to keep that from happening. But there are also plenty of methods out there that have optional arguments, like built-in Python methods and JavaScript methods that have default arguments that'll break if you misuse them. So it's not unique in this case.
Would the user have a way to look at the source code like this?
That depends on, on how it's set up. Like if this was running in the background of a Django application, for example, your user, in most cases, unless they went to the original GitHub repo, wouldn't be able to find this method. It would just be running in the backend, kind of invisibly. But, there's, if they went to like the GitHub repo, they might be able to find it. But then they shouldn't be able to actually run it manually unless they have the ability to actually access your backend using some kind of user privileges. So essentially, if you've been hacked, then yes, they could. Okay. So let's do our last one, Roman numerals. So my gut tells me that this is probably the hardest one. Am I wrong?
I don't think you're wrong.
Yep. So let's figure out, okay, what's a base case and what's a recursive case? We know we're going to be having to change our num and break it down into smaller and smaller pieces, right?
right?
So how do we know we've reached the end?
When num equals 0.
Yeah, so num equals 0. And our recursive case would be num is greater than 0. All right. So we know that our first step would be to create a dictionary, converting numerals to numbers. All right, but then what? So last time we did this, we looped through our dictionary and checked every single key, right? Do we still need to do that?
Yeah.
Mm-hmm. Yeah, that's still the most obvious way to do it. So in that particular case, so we can combine a loop and a recursive function. So we can say iterate through our dictionary. And then we're going to say, okay, if we find one where last time we did this, we said, okay, if the value is greater than our number, then we got to do something, right? So if num is greater than dictionary numeral, what do we do? Or is less than. That's what we want to do. Or is it greater than? Now I'm confusing myself. Greater than. I was right the first time. Sorry about that.
So like if the number is greater than the dictionary number, then add it to a string or something like that.
So we'd probably want to say return that numeral plus, and then we'd want to call our function again. So Roman num minus, so plus Roman num minus num minus our dictionary numeral. But we haven't, so that's our recursive case. We still haven't hit our base case, right? So we could probably check that before we even start our loop. So if num equals 0, what do we return?
False, nothing.
Yeah.
Or a blank string.
Yeah, we could just return an empty string, because that means we got to the end. So let's try this out. So first I'm going to, luckily for me, I already have this copied and pasted, but I need to make these into strings. I'm gonna just indent these for my own benefit because I don't like how it looks without that. There we go. So here's our guide of Roman numerals. And then we say, first off, if num equals 0, we return an empty string. Get rid of the pass. Then we iterate through the dictionary. Let's say for numeral in Roman numerals. And in this case, numeral is always going to be the key when we do a for in loop using a for in loop in Python, right? All right. All right, and then as we go through that, we say if num is greater than Roman numerals numeral, then we want to say return numeral plus Roman num with num minus Roman numerals numeral. All right.
Is it Roman num or Roman numeral? I guess I'm getting confused with the snake case and the.
Yeah. Oh, yeah. I was doing that wrong. Let me change that.
Is there some practical reason that the naming convention is different for different languages, or is it just sort of passed down from generation to generation?
Yeah, it's one of those things that it's mainly there as convention, just saying, okay, we all know that we're all doing the same thing, which makes things convenient. But practically speaking, if you use camel case in Python, nothing's going to happen. It's still going to work the way it's supposed to work. Okay. Any other questions about this solution that we've created? All right, we can test it out real quick. So we call this Roman num. Let's pass it in 95. Uh-oh. All right, it says right here, type error can only concatenate string, not none type to string. All right, so what did we do wrong here?
Is your numeral there, your return statement, your numeral is a number, or is a string, and you're calling a number and you're trying to combine those two? Is that right?
All right, so we want to say we return numeral, which should be a string. That's what we're hoping, right? And then we'd want to say plus the return value of the next call, which should also be a string.
Oh.
So that tells me that something is not what I think it is. So I'm going to print out numeral, see what we get here. All right, we have XC and IV. And we also want a greater than or equals here too, before I do anything else. Oh, okay, so maybe that greater than or equals to was the problem. I'm not sure why it was yet, because I just saw we were missing something and changed it. So I'm going to try it with some other numbers and see if we can recreate the error. If not, then the problem was that we were calculating incorrectly. So 472 CDL XXII, that looks right to me.
I think it's because if num doesn't equal 0, then without a return statement, it will return none.
Yeah, what I'm guessing now actually is that we probably had at some point num got turned into -1, and that we didn't have any kind of case for that. Num didn't equal 0, and then it looped through this and it couldn't find anything greater than Roman numerals, so it just returned nothing. It just returned none. Okay. So that's the last of our challenges. What questions do you have about the recursion challenges? Did anyone do anything radically different with their solutions?
Yeah, mine's quite a bit different.
For which one?
For Roman numerals, recursion.
Yeah. Do you feel comfortable walking us through that?
Yeah, I'll try my best.
Cool. So if you like, I can just pull up your pull request on the main one.
Okay.
Now that is Tommy talking, right? I didn't.
Yep, that's me.
All right. Where are you?
Maybe Control F, Tommy. I think I put my name on there.
Apparently not.
Okay, I can share my screen.
Okay, yeah, that works too.
Let me just pull it up real quick. Okay, and then okay, can you see my screen?
Yes.
So my base case was the same as ours as a class. If number is less than 1 or 0, I guess, just return that empty string. And then I just have all of my else if statements every time the Roman numeral prefix changes. And basically what I'm doing is I'm returning this string right here, and I'm concatenating the recursive call. So return, so if it's like 1000, then we could just return M, and then of course make that recursive call minus 1000, then return that. It would concatenate an empty string with M, and then so on and so forth.
Okay. Yeah, that's an interesting solution. It's definitely more lines of code, but that's not exactly a problem. You know, lines of code doesn't change things too much. And I don't know, my gut says this might actually be more efficient in terms of processing power, because it's not looping as well as recursing. It's just having the switch statement here, essentially.
Yeah, I just did it this way because this is just a really easy way for me to visualize exactly what's happening. I'm not sure if that's something that's used in the industry, but the really simple code like this, where every recursive call pretty much looks the same, is pretty easy for me to understand. So I think that's how I came up with this one.
Yeah, this is one of those cases where a kind of a more snobbish developer would say that this is not an elegant solution, but if it works, it works. So, like, I wouldn't pay that too much mind. And in a problem like this, where we have very limited scope of what the possibilities are, then it works great. So good job.
Cool, thank you.
Okay, so let's take a 5-minute break. So be back at 9:23, and we'll get started on binary search.